Hi there. Today I'm going to be talking about how offensive and defensive structures evolved throughout time. Not talking about chemical or, let's say, camouflage because those aren't structures. Now, when you think about offense and defense, something you might think about is a T-Rex for offense, its sharp claws and teeth, and maybe a Triceratops with its horns for fighting off a predator. But did it? But in what order did they evolve? Did the teeth and the claws for offense come first, or did the defensive part of, say, horns come first? When looking into it, I found that Cloudina, a little tube worm thing, was the first had the first animal with the first defensive structure. As you can see, it has this hard outer shell that just is really hard to get through. It was found It's known to have been appeared around 550 million years ago. Um, and yeah, just the first defensive structure. So we see defense definitely came first. Then we have the Anomalocaris, an apex predator from around 540 million years ago, so 10 million years after the Cloudina. It has these little claws at the front used for grabbing prey. Um, the Anomalocaris actually came from the Cambrian explosion. The Cambrian explosion was an evolutionary arms race that led to the introduction and creation of new species. It led to a lot of animals with harder outer shells, like the nautilus up here, and a lot of offensive structures as well. One offensive structure was the emergence of jaws. Animals turned their gills into jaws. So I forgot to say, Cambrian explosion also introduced fish. But yeah, those fish turned their gills into jaws. So we see this in this fish right here. It has a jaw because its mouth is open. This let animals be able to eat larger creatures than they previously were able to with the small circular mouths that they had, like this tube worm down here. After they got jaws, we see the evolution of armored plating, like in this Dunkleosaurus. Um, Strong outer scales, just to protect the fish. And this was about 420 million years ago. And at the same time, we also see spiny fins appearing in fish, used to hurt prey when they are, or hurt predators when they are attacked, and deter predators from eating them. We also see the specialization and emergence of teeth. We see needle teeth used to just capture prey. It just sticks those teeth inside and doesn't let go. We see serrated teeth used to tear flesh. This would be used against softer animals, softer fish. And then we also see crushing teeth, which would be used to crush the shells of animals like the nautilus that I showed earlier. So that way they can get to the fleshy insides. And we see recurved teeth. These would keep animals trapped better than the other three. So if they swallowed one whole, it wouldn't be able to escape the mouth. Now, when looking into land animals, we know that the lobe-finned fish was the first fish species group to go onto land. These guys had teeth and jaws like we saw earlier, and those were the main things that they kept from the list that we've gone over. Over time, the lobe-finned fish descendants separated through evolution and evolved into different species. These species developed similar traits over different periods of time. For example, the claw of a falcon, the claw of a dog, and the claw of a cat. The dog claw would be sharper in the wild. We also see thick and loose skin as a defensive mechanism in land animals, such as the elephant and honey badger, and we see the armor and quills of armadillos and porcupines, who also evolved separately. And lastly, we see venom glands in predators and poison in frogs and other animals like that. The cool thing is these guys all developed it through the circumstances in which they were around and not through a common ancestor. So it wasn't an inherited trait that was passed down in any of these. It was just certain circumstances led them all to develop the same similar structures with similar capabilities and purposes. And that is called convergent evolution, when multiple animals and species reach the same evolutionary trait despite it not coming from a common ancestor. And these are my references. Thank you all for watching, and I hope